Digital signature. A digital signature is equivalent to a handwritten signature. It is an electronic verification of the sender and it uses asymmetric cryptography. A digital signature serves three purposes as we have learned earlier, which are authentication, which authenticates the source of the data, in connectionless communication. Non-repudiation. This service with the proof of origin helps the receiver of the data prove the identity of the sender if denied. With the proof of delivery, the sender of data can prove that data were delivered to the intended receiver. And integrity. It is designed to protect data from modification, insertion, deletion and replaying.
Digital signature is very important for email use as well. Let's take example of Alice and Bob to understand digital signature better. If Bob wants to send $10 to Alice, an attacker Eve can intercept this message during transmission and change this $10 to $1,000. Which would mean that $1,000 would be deducted from Bob's account instead of $10 which he wanted.
Digital signature can be used to fix this issue, because digital signature is useful in verifying the source and integrity of the message. Let's see how.
We again have Alice and Bob and Eve. Bob has a public and private key. Remember that the public key can be shared with anyone, either Alice or Eve, or you and me. Now, if Bob wants to send a message to Alice, he would first create a digest using a hashing algorithm. A digest might look something like this. It is usually a string of digits. Then, Bob would encrypt this digest using his private key. This encrypted digest is the digital signature of Bob for the message. Now, Bob sends both the message and his digital signature to Alice.
When Alice receives them, she will do two things. First, she will decrypt Bob's digital signature using Bob's public key, then she will get the digest. If she cannot decrypt the digital signature using Bob's public key, then she would know that the message did not come from Bob. Because only Bob's public key can decrypt the digest generated with his private key.
Second, after Alice gets the digest, she will check the integrity of the message. The way she would do this is, she will hash the message sent by Bob using the same hashing algorithm. This will create a digest. Then, she will compare the digest sent by Bob and see if it matches or not. If they are the same, Alice can be confident that the message wasn't changed after Bob had sent it. One thing to note about digital signature is that, using digital signature doesn't encrypt the message itself. If Bob wants to encrypt the message, then he would have to use Alice's public key, which is known as public key encryption, like RSA, which we learned earlier.